Hi guys, greetings. Welcome back to Mechanics of Vehicles. We are in the lane of CO number 4, analyze the tractive characteristics of vehicle for different types of drive. We know that there are three types of drive that we are allowing into our vehicle. First one is two-wheel drive, second one four-wheel drive, after that all-wheel drive. Since four-wheel drive and all-wheel drive both are coming in the same conditions, there are some sort of difference between four-wheel and all-wheel drive that we can see for later. And two-wheel drive furtherly classified into two types: front-wheel drive and rear-wheel drive. If we offer a drive to front wheels, it comes under front-wheel drive. If drive offers to rear wheel, that comes under rear-wheel drive. We are going to analyze the tractive characteristics for these types of drives and also different road conditions. Recap of our previous topic. In Unit 4, we have discussed about the performance factors of vehicle first. Next to that, SAE tire axis system and vehicle axis system was discussed. After that, the power required to propel the vehicle was discussed. The fourth topic what we have discussed is number of forces that act on vehicle. After that, resistive forces offered on vehicle because of the motion. In our previous lecture, we have discussed about the relationship between engine speed and vehicle velocity. Engine speed can be noted as N in a unit of RPM. Vehicle velocity noted as V unit of kilometer per hour. The general formula for power equal to 2.5 Nt by 60. The engine power available is PE equal to 2.5 N of E, torque at E, that is engine, divided by 60. So that we concluded that the power available at wheel PW equal to transmission efficiency eta T into engine power PE. Here that we can say the relationship between engine speed and vehicle velocity N E divided by V equal to 2.65 G by R. NE by V is directly proportional to gear ratio divided by wheel radius. Our today's topic on vehicle performance unit is force indications on vehicle. We know that there are a number of forces that act on vehicle like resistance, right here, resistance, applied force, vehicle weight, friction because of movement, hook forces, we will discuss later about it, and reactive forces, etc. There are a number of forces acting on vehicle. Here we are going to indicate, or here we are going to find the point and direction of these forces. Our today's outcome is indicate the forces that act on vehicle. It will be considered vehicle to indicate the forces that act on it. Let me assume the vehicle will move in flat road surface that we don't have any obstacles and slope for better understanding, and the vehicle moving in this direction. flat road surface. The axis system that we are following is vehicle axis system as discussed in our previous sessions. So this one is X, here we come Z, and this one is Y. That is longitudinal, Y is lateral, and Z is vertical. Longitudinal is rear to front, lateral is left to right, vertical direction is top to bottom. Now we have to find the number of forces that act on vehicle and the point directions. So very first force that act on vehicle is vehicle weight. We know that for any object, for any instant, the weight of object exactly act at center of gravity of the respective object. Here I accumulate all the components as a single object as vehicle, so that the vehicle weight will act at center of gravity of vehicle. First we have to calculate or find out the center of gravity point of vehicle. To calculate the center of gravity point, we have different methods and different solutions. But here, instead of calculating the center of gravity point, I am just going to find out that, because most of the vehicle or a car has 60-40 percentage vehicle weight distribution. 60% of weight will act at front wheels, 40% of weight act at rear wheels. This is a general thing that we are following in our car or designing our car for better performance. So that by using this one, we can easily assume or find center of gravity will be near to front wheels, because 60% of vehicle weight act at front wheels, 40% of weight act at rear wheels. So most of the weight act on front wheels, so we can easily find the center of gravity point near to front wheels. I just take center of gravity point here, CG location, because 60% of weight act on front wheels, so center of gravity will be near to front wheels. So we have different methods to calculate the height from ground, h, and the distance from rear to center of gravity point and distance from front to center of gravity point. Let me take this as B and this one is A. We have different methods for that. We know that W equal to mg. Now we found the point at which the vehicle weight is act, that is the center of gravity point. Second one, we have to find the direction of vehicle weight. We know it very well, the vehicle weight will be always in downward direction, because the gravitational force will pull the weight, pull the mass in downward direction. So now we know the point at which vehicle weight act and the direction of vehicle weight. It will be like this. I just remove the distance and height. Otherwise it will make you confused. And second one is reactive forces. To maintain the equilibrium of weight, the force offered by road surface is reactive force. I write here. maintain equilibrium because of force vehicle weight. Reactive forces are generated. Generally, reactive forces will be opposite to the vehicle weight. Here I write reactive opposite to vehicle weight direction. So we have two reactive forces that act at front and rear wheels, RF and RR. So these reactive forces will be opposite to vehicle weight, since the vehicle weight is in the direction of downward, that is in vertical direction. It also will be in vertical direction but opposite to that, in upward direction. Now we found the reactive forces acting point and also the direction. A third force that act on vehicle is tractive forces. We know that the purpose of tractive force, it is used to move the vehicle or push or pull the vehicle. By using this force only, the vehicle is moving. It is the accelerating force, whatever you may tell that. So without this force, the vehicle is not going to move. We know that tractive force is force generated at the contact patches of road and tire surface. So the contact patches of road and tire surface, that is what the definition of tractive force. Contact patches of road and tire surface is these 2 points. This one is front wheel and this one is rear wheel. Let me take. The tractive force must act at these points only, but in which wheel the tractive force will be act, that we have to find. So totally we have different types of drives, that is 2-wheel drive, front wheel drive and rear wheel drive. 4-wheel drive. Let me take this. For front wheel drive, tractive force will act at front wheels. For rear wheel drive, tractive force at rear wheels. For 4-wheel drive, tractive force will act at front 2 wheels and rear 2 wheels. Just assume. Now we are having front wheel drive. So the tractive force will act at front wheels. If we have rear wheel drive, the tractive force will act at rear wheel. If we have 4-wheel drive, the tractive force will act at front and rear wheels. On these 2 wheels, on these 4 wheels. Now we found the point at which the tractive force will act. Second one, we have to find the direction of tractive force. Usually tractive force is used to push or pull the vehicle, so it's based on the direction. Now we have the direction of vehicle is forward. Without the tractive force, the vehicle is not going to move. So to move the vehicle or to make the motion of the vehicle, tractive force is needed. So tractive force will be in the direction of vehicle motion. If tractive force opposite to vehicle motion, definitely the vehicle is not going to move forward. So tractive force is in the direction same to the vehicle motion, or vehicle motion will be in the direction of tractive force that act. Since we are having the motion in forward direction, so tractive force will be in forward. If we are having front wheel drive, tractive force act at front wheel at forward direction. If we are having rear wheel drive, tractive force will be in rear wheel in forward direction, in the motion direction simply. If we having 4-wheel drive, the forward, the motion will be in forward direction, so that attractive force will be in forward. So let me take FTF, that is tractive force. I mark here tractive force at front wheels. If tractive force acts at rear wheels, means tractive force at rear wheels will be in vehicle movement direction, or in which direction tractive force act, the same direction vehicle will move. If there is an acceleration, there will be some sort of inertia force will generate. We know that very well. Our fourth force is inertia force. Inertia force generally act at the center of gravity point. Now we know the center of gravity location, so that inertia force will be act at this point. Inertia force is because of acceleration, it is a resistive force, so that the inertia force will be opposite to the motion of vehicle. So I just take inertia as Fi, act at center of gravity, will be opposite to the vehicle motion. We can easily say that. Our fifth force is resistance. We know that there are three types of resistance that is offering to the vehicle motion. So first one is air resistance, second rolling resistance, third gradient resistance. Air resistance because of motion of vehicle offered by air. Rolling resistance because of rolling of wheels offered by road surface. Gradient resistance because of moving of vehicle on a slope, it may be uphill or downhill. Gradient resistance generated because of weight of the vehicle and also the angle of the slope. Air resistance is indicated by RA, rolling resistance indicated by RR, and gradient resistance RG. Since the vehicle is moving on the flat road surface, we do not have gradient resistance. If we are moving on a slope surface, we definitely have gradient resistance. But our assumption is flat surface, so we are having only two resistance by this assumption now. So we are going to get air resistance and also rolling resistance. Air resistance is offered by air. We know the formula for air resistance, that is RA equal to KAAV squared. Ka is air resistance coefficient. Here caps A is frontal area of vehicle base velocity. So air resistance directly proportional to frontal area, because most of the air hit at the area of front surface of any object if the object moves on air. So that we can easily say that air resistance will act in the area of front portion of the car or front portion of the vehicle. We can easily calculate the UDL force as a point load. You know that you have studied at strength of material subject. So I directly convert the UDL into point load. The air resistance will act at the hood or bonnet of vehicle like this. Since it is a resistive force, the resistive force always opposite to vehicle motion. So if the vehicle motion in forward direction, the resistive force or rear resistance will be in opposite direction. Second one, rolling resistance RR, is KR into W. It is because of vehicle weight and also road surface nature. It is also a resistive force, so that the resisting of rolling will be opposite to vehicle motion. We know the direction now, and we have to find the point at which the resistive force of rolling will act. Since it is opposite to the rolling, so the rolling resistance will generate at wheel surface or tire and wheel contact patches, like this. Next to that, frictional force. Frictional force, generally we can say that it is also a resistive force offered against the movement. It creates at the contact patches of the motion created objects, so that the frictional force will act at tire and road contact patches right here. Tire and road contact surface, and the direction, since it is resistive, so the direction will be opposite to motion. Next to the frictional force, we are having hook force. It is because of towing of vehicle. All the vehicle will have a tow points like this, at which we are going to hook and tow the another vehicle. Because of the hooking, this is also create resistive to the motion because of the towing vehicle. Since it is a resistive force, the direction will be opposite to the motion, because it has to tow another vehicle. And the point is hook point. It is a multi-axial force, so that we are having two hook forces, that is in x direction and also in vertical direction, like this. Let me summarize these forces that act on vehicle on which point and which direction. We are having vehicle which is moving on a flat road surface in forward direction. So first force act on the vehicle is vehicle weight, so that we have to calculate or find out the center of gravity point. Let me assume center of gravity near to front wheels compared to rear wheel. The weight will act in downward direction because of pulling of gravitational force. After that, we are having two reactive forces at front and rear wheels, RF and RR, because of vehicle weight, which will be opposite to vehicle weight in upward direction at tire and road contact surfaces, because the reactive forces will be offered from road surface against the weight of the vehicle. We know it very well. After that, we are having the tractive forces may be at front wheel or rear wheel, FTF and FTR. These the forces which moves the vehicle. So the tractive force will be always same direction to the vehicle motion, or vehicle motion will be in the direction of tractive force. That is the correct one. Vehicle motion always in the same direction of tractive force. This is the applied force because of driving torque given to the front and rear wheels, if it is a four-wheel drive. If it is a front-wheel drive, FTF only available. If it is a rear-wheel drive, FTR only available. If it is a four-wheel drive, FTF and FTR will be generated. So like this. Since we have acceleration because of tractive force at front and rear wheels, we have inertia force at center of gravity point Fi in the direction of opposite to vehicle motion or opposite to the tractive force applied. After that, we are having two different resistive forces because it is moving on flat road surfaces. If it is moving on slope road surface, so we have three resistive forces. But here we just consider flat road surface. We have only two resistive forces, Ra and Rr. It will be in front and rear wheels based on the tractive force. After that, we are having friction that will be ordered to rolling resistance right here. Frictional force for frictional force FF, because it is a resistive force, will be opposite to the vehicle motion. So I can add with the resistive forces of rolling. After that, we are having hook force. Since hook force may act in X, Y, Z, maybe in number of directions, but we are considering X and Z direction hook forces, RHX and RHZ. Let us consider vehicle is moving on a slope surface, that is, vehicle is uphilling with an angle of theta. Now we have to find and indicate the forces that act on vehicle. So we have a number of forces. First one is vehicle weight, will be in downward direction at CG point. Second one is reactive force, opposite to vehicle weight, will be in upward direction at road surface, road and tire contact surface. Third one is tractive force. If it is a two-wheel drive, will be in front wheel drive will be in front wheels. Rear wheel drive will be in rear wheels. Four-wheel drive will be in front and rear wheels. Fourth one is inertia force, which will act at CG point opposite to motion. Fifth one is resistance, air and rolling. Since it is moving on slope surface, we are having gradient resistance too. Next to that, we may have frictional resistance opposite to the motion. And seventh force is hook force because of towing. We have 7 varieties of forces act on vehicle on these points. Let me leave it to your experimental thought. We have 7 types of forces. You can easily indicate at which point, which direction the force will act. But keep it in mind, the vehicle is moving in upward direction on slope. Now what you have to do is just make a diagram of four-wheeler moving on a road surface with an angle of theta and indicate these 7 forces on it. Thanks for kind listening, guys.